Hello and welcome back. And in this video, we're going to be building our view models. So let's go ahead and get started. So what we're going to do is we're going to create a couple of files in our view models folder. So let's select Swift file, and we're going to name this one CoinViewModel. And while we are at it, let's create another file. And this one is going to be called CoinListViewModel. All right, so let's go to CoinViewModel first. And what we need to do basically is we need to provide a view model representation of this model that we have within the coin. Okay, so and this is going to be the place where this is going to be basically act as a intermediate layer, a communication bridge between our model and our view. So that's why it's called view model, because it interacts with our view and the model. Okay, so you don't basically interact directly with your model. View does not interact directly with the model. Instead, it actually takes the help of view model, and you're gonna see how this can basically provide some of the helper functions for displaying part of your model objects. Okay, so let's go ahead and create a struct, and we're gonna call this one CoinViewModel. It's going to conform to identifiable protocol because we're going to put this CoinViewModel in a list or a for each. So basically, with the help of identifiable, it's going to help SwiftUI keep a track of which row is being displayed and being moved and basically being animated on, or any operation that we are doing. SwiftUI can actually keep a track of which object within that list is being operated on. Okay, so we are simply going to say ID, and we'll create UUID. This is going to be a computed property, and we're going to return UUID. Going to create private coin property. This is going to reference our coin model. So let's get a name. So ViewModel is going to have a name, which is going to return coin.name. Then we're going to have formatted price. So price that we are getting is not formatted, so we're going to get it in a format. So formatted price. And this formatted price is again going to be a string, and we will have this as a computed property as well. So we're going to create a formatter, number formatter, and we're going to define the locale to be the current locale. By the way, if you want to provide, so this is, I just want to show you this, like, locale.current, because this gives you a current locale. So if you remember in our coin service, we are saying right here, we are actually passing the base as USD. With the help of locale, you can actually find out which locale your user belongs to, and you can even make that part as parameterized as well. So just so you know, in case you're planning to extend it or take it as a challenge for yourself, once our formatter is created, our formatter's number style is going to be currency. And once our formatter is created, we're going to create a string out of NS number. So it takes, we can actually create this using double. So we're going to say double coin.price. And we're going to force unwrap this because I know that price is going to be populated. That's one of the required. So whenever we are actually going to parse the response, it's always going to be there. So I'm going to say let for this one. But if you want to be safe, you can actually optional check this one and return like unformatted or like maybe 0 in this case. Okay, let's create symbol property, and this is going to be of type string. And here we're gonna simply return coin dot symbol dot lowercase. Okay, let's also get color. So color we get in string. Now what we need is basically a way to convert our hex color into an actual color object, right? So we need something like an initializer that takes hex value for coin.color and then gives us a color object, right? So how can we do that? Well, that's actually a good candidate for an extension. So let's go ahead and get an extension created. So we're going to create an extension here. New file, and can select Swift file, and I'm gonna name this color plus extension. Okay, and we're gonna import from SwiftUI. Gonna put an extension on color, and we can simply create an init that takes an hex value as a string and give us basically the color. So we can actually create an extension for UI color in this, so we can easily parse this. So UI color, we're going to create a convenience init. So convenience init from hex string, and here so what we're going to do is we're going to get colors like 34, for example, this format, or AA, for example, right? So what we need to do is we need to make sure if this has any leading or trailing white spaces. First we need to remove that. So we're going to save our input string is equal to hex dot trimming characters in character set dot white spaces and new line, and we're gonna take that and convert it into uppercase. Okay, then so let me take this out because we don't need this. Then we're gonna check if the input string has a prefix of hash. Okay, because our user can supply it with hash or without hash. So if it has hash, then we're gonna simply remove that by removing first index or start index. Okay, so this gives us basically removes that hash from the string. Next, we're gonna create RGB value unsigned int 64, and we're gonna use scanner to scan the string and scan for hex int 64 in this RGB value. Okay, so it's gonna basically an in-out variable, a reference we are passing for in RGB value, and the scanner is gonna scan and give us that. So if you look at the output format, it scans for long values of hexadecimal representation and returns a found value by reference, right? So you get that value back, and then you can actually operate on that value by simply saying self dot init, and basically we know that UI color, one of the initializer, takes red, green and blue value, with alpha, and we're going to populate these. So we're going to use bit operation to bit manipulation to basically seek the correct area, so we can actually use bit shift. So RGB value, and we're gonna apply 0xFF. So we need first 2 and shift this by 16 bits and divide this by 255.0. Alright, so this is gonna basically get us the red value. Second is gonna be the green value, which is the middle part. So we're gonna take the middle 2 and shift them by 8 bits. For the blue value, it's gonna be last 2 and no shift operation we need. And we are gonna once again divide this by 255. And then for the alpha, it's gonna be CG float 1.0. Okay, so now what we can do is we can use this init to get our color object. So we can simply say self.init from UI color, and UI color also takes that hex value. So we can simply supply that and get that value back. Okay. Now while we are here, I'm gonna paste some more colors, and these are created with help of color literal. So I'll show you how we can create color literal. So let's say let's sample, and what you can do is use color literal or color picker within Xcode by creating color object and simply type color literal. So wait for color literal, and then you have a picker. So you double click on it, you have a picker, and you can even have an eyedropper. So you can eyedrop to find particular color, or you can paste hex values for your colors as well. So that's another way you can apply your hex values. But having an initializer, a code based hex converter, is actually great, because when we are getting these hex values from the API, we can take them and directly convert them into color objects. Okay, so let's head back, and what we're gonna do is we are gonna continue working on our color model, and we already should have our color. This issue should get resolved, so let's go ahead and build it, and we should have our color being converted into color objects, or string being converted into color object. Okay. All right. Okay, there we go. So let's go ahead and create change. So change that has taken place since the last reading is what this value is, and we're simply going to return coin.change. Next up is history, and this one we actually need double value to show on our graph, and we need to actually normalize these numbers, because if you remember, like, from the API, we are getting all sorts of responses. So let me show you what we are talking about. So I'm gonna pull up the API again, and if you notice, this is your Bitcoin, and as you can see, Bitcoins has numbers in 9,000s, right? But if you scroll down and look at Ethereum, Ethereum has numbers in 200s, like hundreds, right? And if you scroll down even further, this is 1, and if you scroll down, this is in zeros. So what's happening here is, like, numbers vary in different ranges, but in order for us to use this within a graph and plot it on the graph, we need to normalize these values. So the way we're gonna normalize, there is a formula that actually takes minimum and maximum within a given set, and actually applies that formula to convert them into another range to scale them. Okay, so we're gonna implement that formula. It's basically basic normalization. So if you Google it, you can actually find so normalizing data between on the scale of 1 to 10. So if I were to show you guys, this is how this is what you would get. And this is sort of the formula that we're gonna apply for this particular operation, right? To get the normalized value back. But yeah, if you search for normalizing data to scale of 1 to 10 or 0 to 1, you're gonna find out some results. Okay, so let's go ahead and do that, and we're gonna create a convenience function. So let me go ahead and create an extension for that too. So we're gonna create an extension on double. Okay, and here what we're gonna do is we are simply going to extend double, and we're gonna call this converting from. So we're gonna give a input range, so it's gonna be closed range value of type self, so double type, to output is gonna be another closed range of type self, which is going to return self, means it's gonna return double type. Okay, so we're gonna take x value, which is gonna be computed with output dot upper bound minus output dot lower bound. By the way, this is just the formula that I'm applying, the one that we just saw. So I'm just gonna type it real quick. If you wanna know the real math, please check out, please Google it, and you'll find a lot more detail. Input dot upper bound minus input dot lower bound. Okay, and we're gonna return x divided by y plus output dot lower bound. All right, so dot lower bound. Okay, so that actually gives us this is the entire formula, by the way. That actually is gonna help us scale those values back. So let's go ahead and go back to our CoinViewModel, and here we are first going to create our history numbers. So we're gonna get coin dot history dot, so we're gonna map them, and we're gonna transform the value that we are getting. So each number that we are getting, gonna cast them into a double value. Okay, then we're gonna get min and max for this. So we're gonna say his nums dot min will give you the minimum value in this range and in this given array, and max is going to be his numbers dot max. Okay, and we can force unwrap those two as well. Our computed value, so this is where we're gonna create our computed results, scaled results basically, double, and we're gonna say for item in his nums computed values dot append, and we're gonna take our item, so each individual item that we have, converting, so we're gonna apply our converting convenience method, and we're gonna give min max range, so that's gonna be the given range we are converting from, and 2 is going to be 0 to 1. Okay, so it's gonna basically normalize that, and we're gonna return this computed values. Okay, now for we also need an initializer. Basically, initializer is to initialize this private coin, so we're simply gonna say underscore coin, type coin, and self.coin is equal to coin that's being supplied to us. Okay, now for our list model, it's going to be rather simple. It's not going to be much. First of all, it is going to be a class type because this is going to be an observable, and we're going to need combine. So it's going to be an observable object. So class coin list view model observable object, and we're going to have a published property here, coins of type CoinViewModel. Now remember, this is not coins, this is CoinViewModel. And then we're going to have private let coin service, and we're going to initialize our coin service class here, struct here. We're also going to create cancelable to hold any cancellables. So what happens whenever you're working with publishers, if you don't have a place to hold them, they initially get deallocated. So with this any cancelable, you can assign any cancelable publisher into this, and whenever object gets deallocated, these this class particular any cancelable that's holding those cancelable values is also going to get deallocated. So there are less chances of having a memory leak in case of publisher and subscriber model. Okay, that's where in combine you're going to mostly see either any cancelable or a collection of any cancelable that's always been initialized. So you can, it's kind of like a dispose bag if you have used RX Swift. So you actually kind of like put your objects in there and they get deinitialized when the class gets deinitialized. All right, so next up is our function that actually gets us the coin, get coins, guard let. So we're going to use our coin service instance method, get coins, and if we don't get anything, we simply say no data here and return. Okay, otherwise we're going to take our cancelable and we're going to assign that into get whatever we're going to get, basically assign it to that. So let me write it that way. So get coins, first of all, it's a publisher. We're going to sync. By syncing, we're actually subscribing to those events that are being generated. First is the completion. So completion always returns either a finished event, some sort of finished event, either a success finished event or an error. So let's say if we get an error, so we just simply say error and print error if there are any, like that. And it also gets the response, the value that publisher is publishing, so which is going to be coin response. So coin response, and we can simply take that and assign it to our coins by saying coin response dot data in it, take coins from that, map it to coin view model, and we're going to use the initializer that we have created that actually takes a coin, and we take each coin and basically map it or basically cast it back into CoinViewModel and add it to our coins. Okay, and then we are done. So now if you look at it, like, you know, this is saying that result of call sync is unused, and what sync returns is is cancelable. So any cancelable. So we can simply say cancelable is equal to this. Okay, so that way, like, you know, we get, like, you know, this gets deallocated, the subscriber gets deallocated, and publisher eventually gets deallocated, so there's no chances of memory leak. All right, so that brings us to the end of this video, and in this video we created our view model, our list view model, couple of extensions, color extensions, and double extension for normalizing our values for graph. Okay, so this is it for this video. By the way, don't forget to like, subscribe, and hit the bell icon for this channel, and that way, like, you know, you're always aware of what's coming up new, and and we know that you're liking the content, so please subscribe to our channel, and I will see you guys in next video where we're gonna be creating our UI so we can put all of this together into a nice visual looking, or finishing our app basically. Okay, so I'll see you guys in next video. Thank you.